Hey guys, we're back. Or actually it's just gonna be me this week. And I'm super excited to jump into it. If you have any questions, throw it in the chat and I'll try to respond as quick as I can. I see someone's in Florida. I'm down here in Southern California, Houston. That's awesome. So yeah, we're excited to jump into this. I'm gonna start at the very beginning. And we're just gonna go ahead and walk through all these operations, what I chose, the geometry selected, to get the tool path and the simulation, the part cut out exactly how we want it to. And so yeah, excited to jump into it. Alrighty. Yeah, as everybody starts coming in, just say hi or tell us where you're from. Again, if you have any questions, I'll try to answer it as best I can. But I'm just going to start from the beginning. So, when you select the CAM part, obviously you grab your CNC machine, your post processor. You're going to get your coordinate system. I selected the outer diameter and then the center of revolution face. It auto selected my Z. Stock, I just selected 3/4 inch stock, which is what we're using for this specific part. Nothing really in the part settings, didn't have to change anything there. I again had to go through my iMachining database, select my machine, and as well as select my material. And so I'm actually going to give you a quick run through on exactly what you need to set up your iMachining database. Luckily for this one, our post-processor team went ahead and selected all the parameters, and from the manual got everything we needed. But if you needed to start a new one, you could grab new machine. Let's just name this test for now. Spindle speed max is going to be your max spindle speed of the current of the spindle that you're using on the machine. Feed rate max, again, max feed rate of your machine, and then the max spindle horsepower. That is going to be, how much horsepower you're going to have and how fast we can push it in iMachining. All right, so once we save that and exit, and again, you'll select it, you'll create your material. The only thing we need here is our tensile strength. And then I like naming it, whatever it is, and then I like to put it in the non-grouped material here, so I don't have to, go look for it. It always is going to pop up at the top of that level, of the top of the selection there. So pretty simple stuff. You can go on MatWeb, you can find a scientific paper, that was published about the material you're using, depending on, what crazy stuff. But MatWeb seems to be pretty fast, and easy, and a nice selection of materials there. For this specific machine, Swiss machine, you have to set up a few parameters, and to do that, it just depends on the machine and what it needs. So for this one, I did my spindle speed during cutoff, how far past the part do I want to go, or past 0 do I want to go, to make sure that's cut off. Parting feed rate, if you want chip breaking on there, and then you can put your max spindle speed in there as well. And then from there, we're good to go ahead and hit the green check mark. And I see we have a Fort Worth, Texas. That's awesome. That's awesome, guys. Glad everyone's getting in. Again, I'm from Southern California, born and raised. So now we're pretty much ready to go ahead and start. The only thing I do like to double check is coming to our sub-spindle here and making sure that it's mounted where I wanted to pick it up. And for right here, you can see it's off of Mach 2. It's 40 thousandths from the face. So, and once that's set, you're pretty much ready to go. Make sure that you're selecting what Mach position you're going from. And then, yeah, pretty much basic stuff. We're going to do an OD turn on this just to make sure that we finish all these, the face or the top side of these blades here. These are really thin, and it was really difficult cutting this on the machine as well. And if you come to Westech, you'll be able to see what we had to do to get it to work, but I'll also show you right now. So, but simple OD turn operation. I just selected, you know, the faces of where I wanted to start and stop. Make sure it's going in the right direction. I did modify the geometry to go to the end of stock just in case. That's pretty much that. Selected my tool, and you can see the tool here in the machine. Got everything modeled in. Awesome. And then from there I can select if I'm going to do a finish only, if I'm going to do a rough. So this is straight to finish. Since we're working on a Swiss machine, it's got that rigidity because that guide bushing is there. ISO turning method, entire geometry. I did not break any of the edges or anything like that. And then I did choose a retract point because I didn't want it to suck it all the way back in the guide bushing. Unneeded movement, but that's pretty much that one. All right, and then I did a manual turning operation because I'm going into the target model. Because we're using automatic updated stock in our turning module, I need to use a manual turning, and then I went into the geometry after just selecting this line right here, and I did a negative X offset, which allowed me to cut deeper than the target model, and just to finish the face after we did the engraving there. I also added a 45-degree angle with the 40 thousandths extension on that 45 degree, and then I extended this 40 thousandths past the end of the face here as well. And we're good from there. And these are pretty simple tool paths. Swiss machining it's just milling plus turning, or turning plus milling, turning first. Yeah, so let's go to the next operation. So this is when it gets a little hairy. This is the rough that we did with a 2mm ball nose. And to do that, I just went over here to my SolidCAM multi-axis, selected multi-blade machining, and then I chose the roughing technology, and I did parallel to hub. I selected the splitters here, and I did them in a group of the the 3 splitters right here. So that's how I've been sectioning it. I'm pretty sure that that it is the best way to do it. And then I selected the hub geometry here as well, and then I gave it an offset on stock to leave. And these are really thin, so just a little bit of stock, because we are going to finish it with a 1mm ball nose. A little bit of stock goes a long way. And then let's see, selected my tool. Levels, I used a sphere instead of a cylinder, which is the default choice. Toolpath parameters, I messed with the splitter flow line a little bit, and what that is how, if it's going to be nice and smooth, or if it's going to stop and go around it, which is what I wanted to do. If you do more splitter flow line, I saw that it would split the tool path, so it didn't come as close to the tip of the blade there. So just playing around with it to see exactly where it would go and what I would get with different choices is what I would do. Tool axis smoothing, I just left it pretty much in the standard place. It looked pretty good. For our step down and step over, it's going to be your layers and slices. Our step down or layers is 30 thousandths, and our step over is 20 thousandths. And then we go to the sorting. We're going from left to right, and we're starting from the leading edge. All right. And then I gave it a tangential extension on the trailing edge up here, just to go a little bit further past the the OD of the part. We gave it a slight machining angle limit, just telling it not to go past 90, and at 90 axially, so it's stationed like at a 0 or -90, and we said I don't want it to go past, you know, 90 degrees or 0 axially. And then link, I let it go automatic. I did turn smooth link on, which is why you see that nice little curvature retract there. I thought it looked nice. It looks good on the machine. No check surfaces. It did pretty well off of that. We have another person from Houston. That's awesome. Oh, he's in. Okay, 2 guys in there. Awesome. All right, so where did I leave off? Stock definition, I let it do updated stock. So as updated stock calculates up here, that's what the the operation is looking at. And we did have to add a rotation. That's pretty much a translate if you'd use it for other operations. And so just translating it 5 times, looking over here, how many different sections are there. And it was pretty much good to go. And that's it for that toolpath. As for the rough 1mm with the ball nose, just to clean it up a little bit, I just did a save and copy just with the tool change. So, and that would just go back a little bit further, a little bit deeper. I did change this. I was messing around with this earlier. I'll also actually switch that back to what I had it for the other one. 5,000. And we'll just save and calculate. Now we're gonna have to do it for everything. All right. All right, for the finish hub, that's where you come up here and just change the technology. So the first 2 are roughing. This is the first finishing. It's going to be doing the hub first. And for that, I just selected the splitters again, same as the roughing, and I selected the hub. And we're still using that 1mm ball nose end mill. And from there, it's pretty much the same. I did mess with the step over. You know, it's 2 thousandths to get a really nice surface finish on it. Left to right ordering, pretty much standard, just as the roughing. Yeah, this one does have blend splined direct, so it should be moving pretty fast over there. Also kind of looks cool with how it kind of gets off the cut. Could be wasting a little bit of time, but this is a show part. You have to keep that in mind. And let's see, no, we didn't put any gouge check on. Stock definition style, automatic. I think I just left that one at default, didn't look at it. But you could change it to automatic, auto updated stock if you wanted also. Let's see, let's get this one. This is the blade finishing. This one's a little bit different. I did select the fillet, so the bottom of that specific blade, which I was doing the large blades first here. And you can see just the bottom fillet, the edge between the hub and the blade face itself is going to be the fillet. The shroud is going to be the top of that blade. That's what that is called in our software. And then the hub, and then for the blade, I only chose the single blade for this one, just so I could get one blade at a time here. And I'll go ahead and save and calculate that so we can see that. Might take a little while. But everything else is pretty much the same. The toolpath parameters are slightly different. And we'll see that. And that should just be our step down or step over. There we go. Technology, yep, by number of maximum distance. So 2 thou, 5/10. And we're doing spiral, and we're conventional cutting, just so we don't grab that blade and bend it, because it's such a thin blade. I think we're looking at about 12 thousandths thick. So being real careful. But you can see the toolpath looks really nice, and I'll even use our SolidCAM simulator here and show you guys what it looks like as well as we cut it. Now this won't show the machine. I'll do the machine later, and so you guys can all see it. It does look really good on the machine simulation. Where are we cutting through there? Boom. Does look good. Oh, it looks like we're going through on this one. We can always go and change that. And that's pretty much what it is trial and error, what's working, what's not. And I think this is because I messed with this just a moment ago before I started the live. So I'm going to change the center height. Let's go over here just so it knows not to crash into it. Made it way bigger, okay, but it doesn't look like we're crashing anymore. And you can always come back in here and you can adjust it to get exactly what you want. I had this problem earlier with another one, and just playing with it got it to function and look like what I wanted to. It just takes time and sitting there messing with it. And let's go here. Let's go back to finished blades. That's what I wanted to see. But I hope you guys like this different kind of content. We're also going to be filming some stuff at West Tech, me and Kevin together, so that should be fun, and you guys will be able to see that on our LinkedIn and social media pages as well. And we got our stock about to finish here. All right. So now I can do back to SolidCAM Simulator. Let's check this out. All right. Let's give it a second here. So I'll verify. Okay, there we go. All right, let's go ahead and play, and you can see the other tools there. You can see it cutting. Really cool. It's really cool to watch in the machine simulation as well. It looks really, really nice. Same thing on the machine. It looks really, really cool. It's very impressive. But yeah, speed it up here so you can see go faster. And I don't know if you guys used our SolidCAM simulator. Every time I call or talk to somebody on support, I'm always trying to get all of our customers to use them. So if you ever do talk to me and you want to ask me about it, I'll show you how to use it whenever you call the support line, if you guys are customers. Alrighty, yeah, it looks really good. Yeah, and then it keeps going because we have that rotate in there, same as the other one. And then we have another one, does the exact same thing. The only thing I changed on it for the smaller blades here is just selected the new fillets that are right next to the hub. And then I selected the blade itself, and then I did do the shroud as well. The hub stays the same. And yeah, pretty simple. 0 offsets on everything. Just reselected my tool. We're good to go. We calculate that. Another tip, if you hit C on your keyboard, it calculates the highlighted operation. Just so we can at least see it. And this is all pretty small tooling. You'll see if you go to West Tech, we're using, I think 2mm is actually the largest end mill we're using. And 1mm is going to be our finishing ball end mill, and then we're also doing some iMachining on the back side here, and that's going to be a 1 millimeter square end mill. And again, it's going to be really impressive at the show. I can't wait for you guys to see it. Maybe we'll include some clips of it in our next night class as well, so everybody will be able to see it. No, I don't want to calculate the other ones. Let's get everything else done. And we're about to dive into, besides our engraving and everything, which is pretty straightforward, we'll dive into the MCOs. And then once we go through the MCOs, we'll also do, in the iMachining at the end, we'll do a quick synchronization, and I'll show you guys how to sync up all the operations to do simultaneous cutting on main and sub. Yeah, we just used it just because it was easy to get ball end mills. I do see a lot of people using the lollipop end mills, but we just did it out of sake of cheap and easy to program with. The program looked fine with the ball end mill, and yeah, it was that's just what we decided to use on it. But yeah, I have seen a bunch of people use the lollipop style end mills. So yeah, I mean, you can go either way. The one of choice definitely is probably going to be the lollipop. But again, this is just a show part. And you get to see probably a lot more of the B-axis rotation with a ball end mill because it's trying to stay away from gouging it. With the lollipop, you know, you could just send the sucker in there and almost do just a 3-axis toolpath because there's so much clearance around that ball. So, but yeah, again, just a show part, not manual. This isn't a production. So, but yeah. Okay, so everything's calculated. I can show you. I entered an MCO in here, and that's B-axis position. So all it's doing is, after we're doing the 5-axis simultaneous cuts on the finished small blades, that was the last cut we did for the 5-axis simultaneous. I want to home the B-axis head. Yeah, totally fine. So we want to use the B-axis head position, and so you just come over here, you can right click, you can hit add MCO or machine control operation, and then I went in here and selected B-axis position and what channel to output it to. It did 1 and 2, and then I made sure that it was 90 degrees as well, and you can see that right here. When I click on here, it should home the B-axis for us. And the next thing we got is the engraving. Okay, so since we got the engraving, show you, just selected all the text here. I did that just by faces. Went and grabbed my tool, just engraving tool. Selected it. Chose my upper level, the OD of the part, and my depth for engraving, 6 thou, 7/10, almost 7 thou. Seemed to turn out pretty good on the part. You can see that toolpath there. Pretty basic toolpath. All right. And then when I did another cleanup pass over the OD of the part after, you know, just if there's any little burrs that engraver picked up, so that should clean it up. And then I also did the back part here with a grooving tool as well. And then starts the long list of MCOs that we used to do the part off and pick up for the sub. The great thing about this is I can actually select that first MCO and grab the last one, and I just make a template. Create a template. I've already made one for the specific machine. That's gonna be a process template, and then you're gonna name it, you know, part off for, or you could do transfer. And then you can put, if you have other machines, you can put machine specific. So star SR 20R IV4, and this one is a type B. And then you can do include tool data, include geometry filter if you're using the same tool for the cutoff, and you can hit OK. And that'll save it, and then you can drag and drop it onto whatever part you're doing. You're gonna have to adjust just a few things, and I'll show you which parameters you are going to have to adjust. But from there, T2000 selection, that's gonna home the sub spindle in line with the main. So we're ready to do our pickup. So just grabbing that MCO, hitting save and calculate with the related operation, save and exit. Or you can do, I'll do a save and copy, and then I can just come up here to the technology and change it to what I want next. So for this one, it's a Z1 position with tool call. So you're telling how far you want to stick this part out exactly, and you know, you just measure it from the outside of the or the length of the part to the face of the I can't talk to the parting tool. And then you know, so select tool 1, and you can see that in machine simulation, which makes it really nice and easy, so you can actually see what you're doing. I know in other softwares you actually have to you know, export out, and you know, you can actually see this with machine simulation, the whole machine live as you're doing it. Again, makes it really handy to be doing these machine control operations. Spindle speed, how fast the spindle is going to be spinning while the pickup is happening. Spin direction. Now X1 radius call out. So where is the X going to call out, or where's the X going to stop before the cutoff? So you have that starting right there. And then Z1 position, the stick out of how far you want Z to come out, and then feed in for the positioning. So I'm going to go ahead, exit out of this, and now we have a spindle synchronization. This is another one, just like the T2000, that you're just going to grab, and again, it's going to be machine controller specific. You know, what M codes it's going to be calling out to be doing this. So this one's going to be M82 that syncs the main and sub at the same spin rate. And going back real quick, the Z1 position and the X1 position are the two things that you are going to have to set up for when you drag this template onto a specific part, just to make sure that everything is correct, so you're not crashing anything or anything like that. So just going in there, making sure everything's good. Z2 position. So this is going to be where you're going to be picking up the part. So remember, when I set up this part in that Mac 2 position, or the sub spindle, you could see setup location is my pickup, my end position for Z2. So, and you can see it's exact stick out that we had in setup. You can actually grab that by just hitting this drop down right here. You can put in all kinds of stuff. I like doing it setup location just so it makes it easier for me, and I don't have to do it again here. If I just, you know, kind of put it anywhere in the setup. If I do it once, I don't have to do it again. And my approach position is going to be 300 thou from Mac 1, from the original work offset. So stops there, and then it goes to the end position, and it feeds on at 60 inches a minute. You can change it to wherever you want. Air through spindle, just to blow some chips if there's anything on the part. I don't want to get anything in the sub spindle, call it. You can turn on coolant. There's a torque limiter, M68. You can call it status at approach position, open, clamp once it gets to the end position. pretty easy. This is another one that you're gonna have to change when you're dragging it into the template as well. But not a whole bunch, just a couple of numbers to change in. And then you have Z-axis synchronization after you're clamped on to the part, because now you have sub and main both clamped. So you want to synchronize the Z-axis after you do the end position pickup on the sub-spindle. And again, that's just a simple, save and copy from the last MCO I selected and go to technology and change it from there. All right, and then we can just do our cutoff, just simple plain cutoff operation. Selecting the geometry, just selected the face twice to get that little line come down. Grab our tool, pretty easy. Tool number 1. Tool side is important. If you want to offset, if you're going to face on the sub, we're not. It's brass. The face looks pretty good, just with the cutoff, just making sure that the feed rate's good. For this one, you have to do no approach points or none when you're selecting that in the link page. Just a thing that you have to do because it's already set up, so you don't want Z-axis trying to pull it anyway. So it's already ready to go. It's at the X position, it's at the Z position, it needs to cut out, and then boom, you just cut it. It might move just a little bit depending on if you measure everything correctly. But from there, you're good to go. Cutoff's done. Then you can cancel the spindle synchronization and just turn the value to off. Exit. And then this is the Z synchronization, so you're just canceling both of them. And then you also put an end of program with bar change. You're telling the main spindle that, hey, we don't have a part there anymore. It's the end of the program. And then for the Z, you're going to move that away up from the part. Z2 part home after cutoff is just what it is. It goes straight home after the cutoff. All right, so our iMachining. iMachining was super easy. Let's see. It looks like, yep, I just selected the face. Made sure it's eye rough when I finish because I do want to finish it. Grab my tool. Levels are automatically selected because we're using automatically updated stock. We're running it at level 8. You'll see it at the show. It's pretty impressive. Cutting parameters, I didn't mess with anything there. I did do finish entire geometry, give it a RA finish of 16. I pretty much left everything pretty basic here. So just your normal iMachining 2D operation. No, exit. Okay, and then at the end, just added another MCO. Part eject. Simple as that. And when I did add the part eject, one thing that you do have to add is you can add a dwell in there. It's in seconds. You can do longer, however you'd like to put it. Air through spindle, I turned it on, yes, as well. For this specific one, there's a plunger, a spring-loaded plunger, so the second that there's no pressure in there up against it, it'll just shoot it right out. All right, what's the next one? Cooling through spindle, you can turn that on if you got it. Spindle speed, I just have it at 0. Check part, eject, just make sure that everything's gone and out of the spindle. If you have pneumatic part eject, you can turn that on as well. And then you do change the Z2 approach position. I have it nice and close there. And then you have your feed as well for the approach. But that is all the operations. Now, it didn't take that long. It definitely took me longer to program it. But as the operations stack down, it's pretty easy. It wasn't that hard to program. All right, let's go to channel synchronization. So we'll dive into that, and I'll start over. I'll show you what the baseline was. So this is it finished. There's even stuff in here that, because we calculated everything and I actually moved stuff around here, you can actually delete some of these. The part eject I cannot, but we'll start here at 0, at nothing. So delete all. I think it usually looks like this. It'll automatically synchronize everything in the order that it's programmed. So you can see the way that it is right now is the exact way that's programmed, and we want simultaneous operation. So that means our operations need to be happening at the same time at the main as well as a sub. And what we'll do to do that is I'll go ahead and delete all of these are called weight codes. I'll delete all those weight codes, and I'll go ahead and right click on the first operation that's happening, and I'll hit add new workpiece. So from there it tells the sub that, you know, workpiece is added, you know, right at the beginning, and we're ready to start machining. I can go ahead and delete that first weight code. I just selected it and hit delete on my keyboard. You can also, you know, for this one, let's say we needed, or we don't need one, or we need to get rid of one, I can hit delete selected synchronization labels, and that'll do the same thing. But as you can see, this is our operations clash view. We don't have any clashes. So right there we have synchronous, you know, cutting happening at the same time. The OD turn will happen at the same time as iMachining, and whenever the iMachining finishes, maybe, you know, in the middle of this 5-axis rough, which would probably happen because the OD turn and the manual turn, which is the finish, happen pretty dang quick. So it'll probably finish then, and then right after it's done with the iMachining, it'll part eject, and then the main and sub won't, or the sub won't keep going until the end of the weight code hits on the main. So you'll see a weight code there. So on main and sub to synchronize them, and then once it hits those, you know, then it'll go T2000, but it'll wait. Obviously we don't have anything in the main, and then we'll have the next two happening at the same time on the main while the sub is waiting for the main to go ahead and go through it, and vice versa as we go down the tree here. And yeah, it ends with the cutoff, and then you cancel all the synchronizations, end of bar, and then after the cutoff happens, the Z2 moves. But yeah, you can come in here, play with this. You can delete labels, see what happens, see what it lets you delete. As long as you're using the clash view to see, you know, what's happening, you'll be safe. But something we can do at the end, machine simulation to make sure that everything looks okay. It might not, it might, you never know. But then you just go back in your operation, start adjusting stuff to make sure that it's all coming out, you're not crashing with anything. That's the best thing about, you know, SolidCAM is we are always looking at machine simulation and all the different verification simulations that we have available to make sure that we're not crashing with anything. All right, Brazil, that's awesome. That is awesome. Glad to have you. All right, so we can see here what we got going on. I can go ahead and run it. Let's make sure it's slowed down. Let's see. Yep, starting the turning while we do iMachining on the back, OD turn, iMachining. I can split up the views here. Let's say I want 2 columns. Let's put that over there so you can see everything happening at the same time. We already got the 5-axis roughing in here. And then you can come over here to the sub side and see that we got the iMachining going on also. Really cool. It was a bunch of fun to program, and I hope you guys come over and see it at the West Tech show. You can go on their map and find where our booth is, and we'd love to come, you know, show you the part and talk to you. So existing customers, people who are looking into us, yeah, we'd be excited to have you there. So with that, keep commenting on this. What type of William? So we're only going to have this star machine there. So this is star SR20R4 type B. You got the B-axis head. You got the sub-spindle moving, 9 axis of simultaneous movement happening as you are cutting. So that'll be the only one that we're doing there. The star booth will also be using SolidCAM. They'll be running a different part. Still really cool. They're doing a lot of indexial 5-axis over there. I think that's the machine that they're using. Yeah, so you could check us out at a couple places. And yeah, please let us know when you guys sign up for this. We do see, you know, what you guys asked for, and if we haven't already planned on what we're doing, you know, we'll take those in and we'll start doing some videos on them. If it's not a full night class, it'll be like a short or something if it's something simple or quick. But yeah, we're definitely wanting to do more videos to help you guys out. And yeah, William, thank you guys. Thank all of you guys for joining and commenting. I really appreciate it. Makes it a little bit better when I'm not sitting here talking to myself, which I am the whole time, but you guys are there. But yeah, well, I'm glad that you guys got to watch it. I hope that it was easy. If you have any other questions, please feel free to reach out to our support, you know, by ticket, call in, email, however you guys can contact us. And yeah, we're super excited to have another Westech show demo part night class all in one. And again, come see us if you're local. We'd love to talk to you. And without further ado, I think we'll call this one done. All right, guys, thanks for joining me. Have a good night.